Hello and welcome back to Alpayo's programming channel, whatever. Last time I said we're gonna be doing objects next, and then I kind of Googled, so how many types did I miss? Well, the value types in particular. So string is not listed as a value type, which is fine, and it behaves like a value type, is what I'm saying. It is an integral type though, but this is the list of value types in C# that I grabbed just now. So I missed the bool type. If you have a bool, usually you don't want to store bools, probably. I'm going into performance, which is nothing. No one was ever. If someone says this is better because of performance reasons, they're probably wrong. And I'm about to say don't use standalone bools for performance reasons, so I'm probably wrong. So just ignore me. Let's just not. So that's a bool, and bool is just like a one bit of information. So it can be 1 or 0. And actually it's actually false or true. It's for Boolean logic, false or true. So these are the only two values that can be. And you can use something that results in a bool or a bool directly in statements that need a bool, like conditional statements. I'm wondering if there are any other statements that need a bool, but functions could require you to pass in a bool, for example. So these would be that. If you have a question mark, you're saying that things can be null. So bool C, if I go and add a question mark on the type, this can also be null. So you can have up to 3 states in a bool if you add a question mark, which is sometimes good if you want to say the connection is good, the connection is bad, or I don't know. Like, you can go for that bool and have the I don't know state be null, and kind of makes sense. Or I don't know yet, I didn't look, I didn't check, I can't make that assumption. Then you could go for that. I've seen it, I've done that. I don't know how useful it is. Well, I know how useful it is in some occasions. So that's a bool. Let's cross it off. Byte. Byte is a small one, and byte comes from. A byte is a set sequence of bits. Now these days it's typically 8-bit. So byte B is. If you go for byte max, for example, byte.max, you can see it's not a big number. It's 255. And if you know your hexadecimal math, you can actually go, so it's 8-bit, right? 1, 2, 3, 4, 1, 2, 3, 4. So this is the amount of bit that is. If you want to express like everything is set to 1, then you can go through all of these and summarize them in a hexadecimal number. So that one would be F, and the other 1111 is also F. So this is the value FF, and you would write that to tell the compiler, hey, I'm giving you a hexadecimal. You go OX, and then you go OXFF, and that's actually 255. So this is how you could do that. Usually don't do that in C#. If you go down to that level, you end up in a different programming language. But where this could be useful is if you have, like, say you have a microcontroller and it has 8 lamps, and they all are kind of behind a like, these are the legs of the microcontroller, and they can be in up or down state. That's actually a real thing that happens in microcontrollers. You want to enable all the lamps, so get all 8 legs into a high state. You go, I should do it that direction. Oh, this is my mask here. Let me move over. So you want to get all 8 of them blinking. You would send that to the legs, which are at a certain address, but you wouldn't use C# for that. So, but maybe there's some connection there, and you might run into that at some point. I don't know, whatever your application is. So that's byte. Character, the absolute same thing as a byte. There's literally no difference. The only difference is that the kind of you can express your intent, because character is like character C is an A, and you want to write A. Now you can't use the big quotation marks, so that indicates a string, and the character is only one character, so it's not a whole string of characters. Although this character only contains one string, still wrong. So you need to go and use the other one, the smaller ones. Now you're saying it's just this one. So you're kind of saying C is now just this one A. You can also go character D is 65, because it can't store numbers. You kidding me? Oh, you can't implicitly convert that. So cheeky. Okay. So there's a conversion connected to that. The character A on the ASCII table is actually the value 65. So that those are equivalent. But it's interesting. I checked this is how wrong it is to do that, because I never do that. Okay, so byte B can be 65 then. So I cannot assign an A to B? Is that what you're telling me? God, I'm messing up my thing here. Let's just go 1, 2, 3. Let's 1, 2, 3, 4. Okay. And now I can't assign that. Oh yeah. So this is how they split it up. Wow, I didn't realize C# did that. It's entirely useless to me. Those are equivalent. I don't know why there's a difference. Because actually, character max, does it tell you character max? Character dot max? /UFFFF. Oh wait. No way. This character is actually 16 bytes long if it can store FFFF. That means it's 16, not bytes, bits. It's 16 bits. Whereas byte is only 8 bits. So these are completely different. I take everything back. These are those are different. Don't ever listen to me. Byte character decimal. Yeah, we had it last time. This is the decimal number. It's a floating point double. Enumeration is value type. Interesting. Yeah, we'll go into enumeration. You basically probably don't want to use enumerations. They behave poorly if you want to get them over any kind of serialization. It's just a mess. I don't know. They seem incredibly useful, but you run into so many issues. Float. Yeah, float. We talked about integers, longs. S-byte. That's a signed version of byte, because byte is 0 to 255, and signed byte. There's actually something to say about that. Let's get an S-byte in here. S-byte, S is S-byte dot, and if you look at the max value, it's 127. If you look at the minimum value, it's minus 128. That's kind of a symmetry thing. If you look at the binary stuff, let's just get 2 binaries in here. So 0, 0. This one is the number value. So let me go and tell this one. That's binary. This is the number value 0. If you add 1 to it, you're on 0, 1, right? If you want, let's make this the unsigned. Okay. Now you have add 1 more, you get 3. No, this is 3, but if you add 1 to 1, you get 2. So, and 2 in binary is expressed like that, see? Okay, right, so you have 0, 1, 2, 3. Now this is the unsigned variant. Now how do you get the sign in here? And there's a thing called 2's complement, where you basically decide, so here you can decide like the last digit, that's a positive 1, and this one is a positive 2, so you can add them like that. So it's 0 times 1 and 0 times 2. This is 0 times 1, which is 1. This is 1 times 2, which is 2. This is 0 times 2 plus, no, this is 1 times 2 plus 1 times 1, so it's 3. Now, if you want to go for negative, what you do is you get the highest bit value and say, no, that's negative though. So you go like, here is this one is plus 2 and plus 1. These are the values here. You line those up. And for a signed value, this one, the first one is negative, and then you have the other one's positive. So if you go through the same table, you get like 0, still valid. This one is 1. That one's minus 2 though. So if you one implementation could be, depending on what the guarantee is because that's overflow. Like if you add anything to the biggest value and you kind of the circle completes and you end up with the next byte value, then this is an overflow. It's typically a problem. There are things you can't do about it. But yeah, sometimes it's not a problem. Sometimes it's intended. So here's 1, and now this one is minus 2, and if you add 1 to minus 2, you get minus 1. See, and if you add 1 to minus 1, it'll overflow and be 0, 0 again. See, yeah, binary addition, you can look that up, of why this, if you add 1 to 1, 1, it does the same thing that it does here, which is it tries to, I need to get the minus in here. So it tries to go for, it's like the same thing as a decimal system. You can't, if you have a 9 and you add 1, because you can't, there is no number there, so you write 0 and 1 in front of it, because that's 10. That's the same thing that you do here. You write 0 and then what you carry the 1, and there's already 1, so you can't do that. You need to add the 1 to this one, and so you can't do that. You write 0 and then you go and write a 1 in front of it. Now if you only have 2 slots though, the first one that just falls off, and it's this value again. So this is how you do negative numbers. Long story short, what I wanted to say is, this is why you can see how the positive number is 1, and the most negative one is actually minus 2. It has 1 more negative than positive because the 0 is in play. You can see that there's symmetry with these two. 0 and 1 are 2 values, and then all the negative values are also 2 values. So it's the same amount of values, just the 0 is with the positives for symmetry. S byte max value is 127 and min value is minus 128, and that's true for all of the integers. Like if you go s int, shouldn't there be an s int? S int dot max value signed in, no, integer is signed in. You don't do s integer. You need to add unsigned if you want it unsigned. Okay, max value 647. See, 647. So what's the biggest negative one number? It's the same with the minus in front and 648 at the end. So let's see min value, 648. See, predictive power. Okay, so yeah, and that covers S byte. Short was that? How many bytes is that? Short. Yeah, that I think 3 to 7. I think it's 16-bit. Not entirely sure, but it's shorter than integer. It's longer than byte. And I think it's 16, but byte is 8 binaries. Yeah, this won't make sense for you, compiler. Just go comments. Just tell the compiler that these are comments. Byte is 8-bit. Short is 16. In integer is 32, and I wrote 42 because that's a more interesting number. Now at least. Actually, the Monty Python was looking for the least interesting number, so they picked 42, which is now the most interesting number. Weird. Long is 64, and actually, is long the same as long? Long, the max value is really big. Oh, this is long, okay. No, this is a constant long called long.max value, okay. And long, does that exist? No, okay, just ignore me. So long is 64, looks like it. You also can go directly, if you go integer, it offers, like C# offers you the exact byte count if you're unsure which one is which, bit count. So you can go int 64 as well, and that's valid. You can use that if you're unsure. Short struct. Yeah, we should talk about struct, because that I've seen struct and I thought, hey, that leads into classes, because you can go from struct to classes and not entirely dissimilar. Just the fact that it's a value type has implications for copying a struct and for generic code, stuff like that. But yeah, integer, unsigned integer, we did that. Unsigned long, it's just the unsigned variant of the stuff. So let's go enumeration, and you can go, well, depending on, see, here's a class definition, and here's a namespace, and here is a static function. Now, depending on who you want to see what you're writing or be able to see, so if someone imports this namespace, should they be able to see your enumeration? Then you would go and write it into this part. It's just about who should be allowed to see it. If you don't care at the beginning, just go put it into namespaces. Let's go, I think it's enum, just like that. Keyword, then the name, because like just class has class, then the name of the thing. So we go enum, the name of the thing, my enum. And then comes the definition of the enum. So enumerations default, and that's important. Defaulting is important. What things default to? If I go right line, right? No, I need to go console. Console.WriteLine. Usually, later you won't use the console because there's the console class itself is a singleton, so that's the first reason not to use it. And the second reason is you're coupling this code to the console, which you don't want to do. You want to have an interface in between. We'll get to that in like lesson 100. Integer A, and now I'm about default. So we just go write line A. What will it write? It actually writes Nothing. No. Oh, you refuse. Such a... Okay, so we'll have to go default, and I won't explain you what it is. It just suffice to say it will now choose the default value for a and initialize a with the default for int. So it'll grab the default value for int. If things go weird, things tend to either be not assigned, which is an issue, or they go into the default value, right? And I can't get it weird enough here. It's just, but this is the effect that I'm trying to show. So it's 0. For integer, it's 0. If I go my enum a, default my enum, what's the value? It's 0. I didn't even define anything in my enum. If I go, so in an enumeration, I'm saying basically, I have a bunch of numbers that mean something for me, and I want them I want to write the name, but I actually want to use the number, if that makes sense. So I want to have a Monday. Let's just have Mo. Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So these are the values that I want to have. Still going to write it, right? So Monday now, because it's defaulting to that. Yeah. And why does it default now all of a sudden to Monday? Because Monday has the value 0 if I hover over it. Because that's what I said, just pick numbers in the order that I give you the values. And I can go a is my enum dot Friday, see? And I can use my enum as a variable in a function where I expect a weekday. Let's actually go weekday. It's weekday. This is my weekday enumeration. Weekday, Friday. Now, if things go weird, I want to be able to detect that they gone weird. So I don't want Monday to be 0. I actually want invalid to be 0. And then we can go on with the, oh yeah, that's another thing that you can do. You can actually just write equals that, and it'll start with that, and then it goes ahead with the next value. Now I changed, actually, by changing the enumeration here, I changed what the numbers mean. So if I have now some hard-coded native code that depended on the numbers, I screwed them over. Because all my stuff can recompile if I just distribute this thing, but everyone else's who has the integer value of it, they can't. So I just broke the whole interface. If you can avoid enumerations, just avoid them. It's not worth it usually. Okay, but now you see that invalid has 0. So if I now default a, I'm defaulting it to invalid, which is great, because now I can say I have an error state. If the enumeration broke, I have an error state that I can look at. Hey, it has 0. This isn't supposed to happen. Something broke, so I can check for it. But as before, I cannot distinguish between someone meant to write Monday or it's an error. So this is why you want to go for enumerations. If you use them at all, 0 is the invalid value. That is just given. And more often than not, you run over enumerations, but don't do that. Okay. Struct. I want to go into struct. So let's have a struct. It's the same thing. You just keyword struct, then the name my struct, or whatever name you want. My struct. Okay, and you can have like an access, so like this is a public struct. No, this is only used inside my computer, inside my solution, this project. it's internal, just for this package. Or it's private. Can I do private here? Private, that doesn't make sense because it's private and now no one can access it. I can do private if I put it into the program, because then it's private to the program. That makes a little bit of sense. I just have it public. Public. You actually, I think for a beginner, the best thing you could write is internal, because that's kind of, it's visible for all of your stuff, but you're not exporting it. If you export things, other people can import it, and if they import things, they can use it, and all of a sudden they depend on the stuff that you wrote without you knowing it, and then you accidentally break them. Now, if I, for example, the enumeration, if I had, this wasn't purely internal enumeration, then no one else is breaking, because it's only this thing. So yeah, internal is a good one. Private might be too restrictive, but there's another reason to make everything public, and that's testing. Okay, internal struct, my struct. Actually, let's go for box. Let's have a box. What does a box have? Like, I'm thinking two-dimensional box has a location, so like maybe an integer for x, an integer for y. No, semicolons. Compiler's right, you don't write it. We can have an integer for width and an integer for height. And yeah, so the semicolons separate what they are. So if you go and give them into a new line all the time, it tends to look prettier, and you probably want to have that in a file as well. Now he's complaining probably because no one can use that. Oh, struct defaults to public, is that right? In a class, this would be default private. In C++ and C#, in C++, there's no difference between struct and class. In C#, structs are value types and classes are not. Classes are object types, objects. So let's make a new class box, struct box. So I'm having a box, box B equals, and we still need a new keyword because we want to make a new box. I think this is the case where everything defaults, right? And then we might want to have a right line box. But this isn't defined yet. So we need to go ahead and write a function that does the right line box. Okay, let's go here. And this is already a jump into what classes will be later for us, because right now we're doing something with the box. Let's just write the function. Private, has to be static because we're calling it from a static method. Box B, go uppercase. Yeah, and then just a bunch of right line statements. Oh, return value, super important. Void. Void means nothing. I'm gonna actually, I'm asking myself how fancy I should be. So we want to go for a string str, and we just want to right line the string. There are different ways to make a string. One thing would be to just go, we start with an empty string and just add them. Box dot, they're not public. Something opened, close. These are not public. Let's go public. B dot, yeah, go x plus b dot y plus b dot width. This is going to look super ugly. B dot height, And now this is one of the cases where I think things default, right? So this is one of the weird cases. Didn't actually say what they are up here. I could have given this a default value of 4. And that one I give a default value of 7. I hope that's how that works. Cannot have that. Instance project or field initializers instructs. All right, I stand corrected. Now, does this one actually default? I wonder, because I usually don't use value types. Yeah, it defaults 0, 0, it's all 0. So this one would have been an example where things defaulted. Now, I don't want this to be possible. Can structs have a constructor? Everyone who can see the box is internal, so I can go for public, but everyone who can see the box is allowed to use this initializers. The return value of an initializer is the you making, well, of the, not the initializer, the constructor. You're making the thing, so you're basically returning the class itself to some extent. So you don't need to specify the return value because it's already clear it's a constructor. So you're making the thing. Let's just grab these. And actually, I wonder if that's a ReSharper thing or it's just generally available. Trying to find, okay, no. I wanted to go and just say initialize from constructor, but I think there's another tool. There are a lot of tools that help you program, and one is ReSharper, and that's a ReSharper thing. Don't have that on my machine here. Okay, let's just go by hand. X equals X. This looks weird, and it is weird because now he doesn't know what is X. What do you mean? Like, we have a locally defined X, and this is this X. So he's assuming I mean that one, but I'm actually, yeah, for the second part, I want that one from the parameter list, but on the other one, I want the one that is in this class. So I need to preface this with this because I didn't choose a smart name. And that's one of the reasons. So you have to write that all of the time, this thingy, unless you do something which is kind of standard in C#. And the standard for C#, this kind of the naming convention. If you go Control-RR, you trigger the rename refactor. So now I'm adding an underline. With enter, I confirm that. And you can see how it grays out this now, because it is now clear what I meant. I meant to use the one with the underdash. And this is kind of, that's the way to go. You can also use Alt-Shift and select a whole column of things and write on every column at the same time. That's really useful to mass edit your mistakes. Okay, and now here I just assigned X to everything. Why did I do that? With height. Okay, so now I can no longer use this default constructor. Why are you not complaining? He should be screaming at me right now. Let's go make these public again though. So it makes sense to have them private and with access restriction, but I need them public or this function everything gets more complicated unless they are public now. And I need to clean up the value types once and for all. Is never assigned. Liar. Yes, it is assigned. Okay. This constructor should not be reachable. Why? Is that something special? Yeah, that seems to be special with value types, that they have a default constructor. Let's go ahead and define the default constructor. Private box, and make this one private. Is that allowed? Okay, it's not allowed because it's a struct. I'm learning things about structs right now. So what I was trying to do is make the default constructor private. That's something that you do in C++, for example, so that you cannot use it. That this would be a compiler error, but looks like structures behave that way. I usually don't use structs. I should. They seem to be great. Okay, let's just use this constructor by adding the parameters to the constructor call. And there we have it. That's a struct. And now the struct should behave just like a value type, which I should be able to test if I do this. And then I write, at the end here, I write b equals new box. And it should have copied that, because that's the value type behavior. 7897. Now it's not used. Yeah, see, this in here is a copy of the other thing. With an object, it would have been a reference, and this time it's actually true that we do references. The object thing is next. This has been a long video, man. 35 minutes. Thank you for hanging in there. I'll try to make them shorter next time. Thanks for watching. Bye.